Good evening everyone and welcome to my YouTube channel. So the question says that, so we are continuing on free fall. The question says that a ball is thrown vertically upwards with speed v from a height h above the ground. Show that the time taken for the ball to strike the ground is this. So it is thrown from a height h. So let's imagine that we have a building, something like this. Then a ball is thrown. Now remember here, what is very important is for us to know what we are going to be calling the coordinate axis. So the coordinate axis tells you what you are going to be taking to be positive and to be taking negative. So if you look at here, the ball, let's say whatever it is, what was thrown, a ball. So if the ball is thrown up there, so as the ball is thrown up, so this is what is going to be happening. So as it is thrown up like that, then it just misses where it was thrown like that. So it goes until it strikes the ground. So now what we are interested in is for us to understand terms such as displacement. So displacement is defined as the change in position. So displacement, by definition, if you move from here to here to here, let's say you move from point A to point B, let's say here it's 10, here it's 5, here it's 10. The distance from point A to point B is what we are going to call the displacement. Displacement is the change in position, meaning to say to find the displacement, you don't have to add 10 plus 5 plus 10, which will give us a 25. You will just have to account for this distance, which is 5 meters. So if this is our 5 meters like that, then we can be able to say that this is our displacement. Displacement, we are just interested in the initial and the final position like that. So therefore, if you look at your height of the building, it's given as your h. If displacement is a vector quantity, meaning to say it has got both magnitude and direction. So therefore, in order for you to answer such a problem, what you are going to have is that you are going to take, as long as it's going up, as long as it's going, whatever is going up, you're going to take it as positive. Whatever is going down, you're going to take it as negative. Therefore, if you look at your gravity is acting downwards, while the ball initial position, it was thrown up, meaning to say the gravity will be negative. Now one thing is common, which is if you push your objects to be up there, this is where we establish what we are going to be calling the coordinate axis. So the coordinate axis simply tells you what you are going to be taken as to be positive or negative. So now, for example, if you look at your gravity, when it was thrown up, at this point your gravity was negative. Since it was thrown up, the gravity is acting downwards, meaning to say your gravity is equal to a negative value. So that means to say at all points, regardless of how it is, to make our physics to be simple, we are going to take our gravity to be negative, even if it is falling with respect to the origin. So the origin is very important. If at the origin it was thrown up and the gravity was acting to be negative, even when it begins to fall down, it will be a negative value. Likewise, even the displacement, which is a vector quantity, will take the negative sign like that. So that is how we go about that. So displacement is the change in position, initial position, to this will be our negative h. So in order for us to reach this stage, we are going to have the equation that can give us a square root. If you look at our kinematics equations, we have v squared should be equal to u squared plus our 2as. We have our v should be equal to u plus our at, like that. Our s is equal to ut plus our half at squared. So we are going to use this equation, knowing that we have our time. We cannot use this one because they want the time and this equation doesn't have time. This one, we do not have, this one cannot give us directly a quadratic equation because we need a square root, and the only equation that can give us a square root is the equation that leads to the quadratic formula. So therefore we are going to use this. So using this one, we are going to say our s should be equal to ut plus half at squared. So we are going to just get this equation. Then the thing that we need to establish is this. The displacement, if you look at our diagram, we have our displacement, which is from the initial position. As long as it's going down, it shall be considered to be negative, since the origin it was going up like that. So we are going to take our negative h because it's below the throwing point. If it was just taken from, if it was just dropped, h could have been positive, but since it was first thrown up, h shall be negative because it is below the throwing point. So we are going to say where displacement is, we are going to put our negative h should be equal to our initial velocity is equal to, we are told that a ball is thrown vertically with a speed v. So this one is our initial velocity. So where there is u, we are going to put v, then we have our time, then we are going to say plus our half, then our acceleration due to gravity, since this thing was thrown up and gravity acts downwards, so we are going to say it will be negative 9.8 like that. Or we are required to show where the gravity is showing, so we can just say negative g like that instead of saying negative 9.8, because in this equation they want our g to still be showing. So we are going to say negative g, then we have times our time squared. From there we are going to have negative h should be equal to vt, half times that, it will give us negative half of g, then we have our time squared like that. Then from there what we are going to do is that we can be able to say our negative h should be equal to, let's take our 2 to be our common denominator, so 2 times vt, it will be 2 vt, then we have 2 divided by 2 times 1, it will just be 2 gt squared. From here we cross multiply, we are going to have our negative 2h should be equal to our 2 vt, then we have minus our gt squared like that. So this equation, we are going to take the gt squared this other side, we are going to have our gt squared should be gt squared, even this one when it comes this side it will be 2 vt, then we have minus 2h, which should be equal to 0. So if you look at this, this is a quadratic, it has got t squared, it has got a t and something that doesn't have t. So therefore we can use the quadratic equation to find t. So t should be equal to negative b plus or minus the square root of our b squared minus our 4ac. Then we have over our 2a. So our t should be equal to negative b. Our b is equal to this. So a quadratic equation, this is our a, this is our b, this is our c like that. Then if that's the case, we can be able to say negative b, which is our negative 2v like that, plus or minus the square root of our b squared. B squared is negative 2v. We square this, then we are going to have minus 4, then we have our AC. So our A in this case is a G times our C is equal to negative 2H like that. Then we divide this over, we are going to have our 2, our A is equal to a G. So our A is equal to a G there. Then what we are going to have is a T should be equal to negative times negative, it will be positive 2V like that, plus or minus the square root of our negative 2 squared will give us 4. V squared will give us V squared, so that the squared is distributed for both numbers. Then we are going to have negative times negative, it will be positive. Then we have our 8. 2 times 4 will give us 8. Then G times H, it will give us GH like that. Then we divide this value over our 2G like that. Now, each and every time you're answering such types of problems, you're supposed to be comparing your equation to the expected answer. So this is our expected answer. Now here there is a 1. Now you ask yourself, here there is a 4. How do I get a 1? So I can get a 1 by dividing 4v squared on both numbers. But you can, it's not just as direct as dividing 4v squared. So what you can do here is you are going to factorize this value. So factorizing is the same as dividing. So we are going to say our t should be equal to, we have our positive 2v plus or minus the square root of, factorizing v 4v squared, we are going to remain with, so this is the same as having the 4v squared over the 4v squared like that. Then we have plus our 8gh over our 4v squared. Whatever you factorize will be able to divide throughout. That's how factorization works, like that. So we are going to have that value, then we have over our 2g there. So we have over our 2g like that. So what we are going to have from there is our t should be equal to our 2v plus or minus the square root. So we have the square root of our 4v squared. Then we have 4v squared divided by 4v squared, it will give us 1. Then we have plus our 8 divided by 4 will give us a 2. 8 divided by 4 is 2 gh. Then the only value we're remaining with here is a v squared, like that. So this is what we have there. Then we have over our 2g like that. So if that's the case, then we are going to just be able to reduce some things. So already we have what we want in the brackets. It's 1 plus 2gh over v squared. So we need to get rid of this. So we are going to say that our t should be equal to our 2v plus or minus. Then the square root can be distributed among these numbers. So we are going to have the square root of our 4v squared times the square roots. You can do this for both of the numbers. We have 1 plus 2gh over v squared, like that. So with that said, we are going to have over our 2g. With that said, we can say that our t should be equal to 2v plus or minus the square root of 4. So this is the same as the square root of 4. You can distribute times the square root of v squared. This is allowed under radicals. So times the square root of our v squared. Then we have the square root of our 1 plus 2gh over our v squared. Then this we have over our 2g, like that. So our t should be equal to a 2v. Then we have plus or minus square root of 4 is equal to 2. Square root of v squared will be equal to, this square cancels with a square root, so we are just going to remain with the 1 inside. So we have v times the square root of our 1 plus 2gh over our v squared, like that. Then this value is over our 2g, like that. 2g, like that. So what we are going to have here is that we can factorize here. As you can see, we need to find a way of having a g v over g. So we can do this by factorizing what is common. So we have this value and this value are common there. So we can be able to say 2v, when we factorize like that, it will be equal to, here, if we remove that value, we are going to remain with a 1 plus or minus the square root of our 1 plus our 2gh over v squared, like that. So this is what we have. Then we have over our 2g, like that. So now when you do this, since these are in brackets, you can just move this number here. So this is the same as having t should be equal to your 2v over 2g, like that, times the square root of 1 plus or minus the square root of our 1 plus our 2gh over our v squared, like that. So this is what we have. So now you can be able to do this as long as they are in brackets and you have one term. You can just take the term here. It's still the same. It's still the same meaning as having this over, like that. So these two and these two cancels. So we are going to have our time should be equal to v over g. Then we are going to have 1. We are going to take the positive square root of our explain y, 1 plus 2gh over v squared. So the reason why we are going to take the positive value is very simple. We know that time can never be negative, meaning to say we do not know the outcome. Sometimes it could be that whatever, let's say we have the square root of, let's say this 1 plus whatever comes out to be 10, and here we have 1 minus 10. Okay, let's just have a perfect number such as a 9. 1 minus the square root of that is 3, and if it's negative, if it gives you negative, which is negative 2, time might come out to be negative. Therefore we are just going to take the positive. So that is how you handle that question. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.